Hello, everyone. Welcome to this Confidential Computing Consortium webinar on the future of attestation in a confidential world. My name is Lily Sturman. I am a senior software engineer at Red Hat, and I am the CCC Technical Advisory Committee Red Hat representative. I will be your moderator today. A quick introduction to the Confidential Computing Consortium, or CCC. The CCC is a project community at the Linux Foundation dedicated to defining and accelerating the adoption of confidential computing. It is a community focused on open source license projects, securing data in use, and accelerating the adoption of confidential computing through open collaboration. Every member is welcome, and every project meeting our criteria is welcome. We are a transparent, collaborative community, and we as members, contributors, and leaders pledge to make participation in our community a harassment-free experience for everyone. We at the CCC also have a whole series of webinars, which you can check out on confidentialcomputing.io/webinars. We have mentioned this topic of attestation in a few previous webinars, so if you're interested, you should definitely check those out. I know there was a talk about the hard facts about confidential computing that mentioned attestation. And we also had an entire webinar on the remote attestation procedures architecture, or RATS, presented by our very own Dave Thaler, who is also on this panel. So if you're interested, please go and check these out. I want to also mention that the CCC has an attestation special interest group, which has been meeting regularly since around March of 2021. These meetings are every other Tuesday at 9 a.m. Pacific or 4 p.m. GMT. And there are opportunities there to do prototyping, integration with other CCC projects, standardization, technology dissemination, and also to fund some in-scope activities. So if you're interested in learning more about that, please check out the webinar description for some links, because there is a special mailing list for the Attestation SIG. There's also a Slack channel, and there are these regular meetings. So for this webinar, we do encourage audience questions. Please put them in the chat as they come to you, and we will probably try to round them up at the end in the last 10 or 15 minutes. And now I want to introduce our excellent panel of 4 experts. So in alphabetical order, we have Dave Thaler of Microsoft, Mark Novak of JP Morgan Chase, Nathaniel McCallum of Profian, and Simon Johnson of Intel. And if you all want to just say a brief few words about your backgrounds and introduce yourselves, I will call on Dave first.
All right, I'm Dave Thaler. I'm a software architect at Microsoft in a group where we do both Windows and Linux things. Within the confidential computing area, I've been working in this area for, I don't know, 4 or 5 years maybe. I chair some working groups in the IETF. So my role on this panel is basically from a standards perspective. The IETF RATS architecture that we had a webinar on before, I'm an editor of the document in that working group. And I co-chair 2 other areas within the IETF that's in the security area. Within the Confidential Computing Consortium, I chair the Technical Advisory Council. And so I do other things too, but those are the ones that are most relevant to here. So happy to be here, and I'll pass it on to the next person.
Thank you, Dave. Mark?
Hi, so I'm Mark Novak. I am Dave's former colleague from Microsoft. I was actually involved in confidential computing for much longer than the moniker itself has existed, and I was the original architect for what became Azure Attestation Service. Now, for the last few years, I've been working at JP Morgan Chase. I'm a director of the applied research team here at the JP Morgan Chase, focused on emerging technologies, and my focus areas are ledgers and trustworthy execution. So in that capacity, I'm the only person on this panel with firsthand interest in how trust execution environments are governed.
Very good. Thank you, Mark. Nathaniel?
Hi, my name is Nathaniel. I'm the CTO of Profian. I'm also the co-founder of the company, as well as the NARCS open source project, which allows you to deploy WebAssembly workloads into confidential computing environments, and frequent contributor to IETF, one of the co-founders of the Bytecode Alliance, and other standards committees like the W3C. So yeah, that's basically me.
Thank you, Nathaniel. And Simon.
So I'm Simon Johnson. I'm formerly the program architect for Software Guard Extension's hardware trusted execution capability as part of the Intel processors. I'm now the confidential compute lead across a range of activities that are happening here at Intel. I've been a member of the TAC for confidential computing. And generally, originally, I was my main task as part of SGX was to help develop the attestation architecture. So I think that has some relevance to today.
Yes, thank you. Thank you very much, everyone. So I want to make this webinar sort of conversational. So I will be asking some questions, and I encourage everyone to jump in as they are moved to respond. We'll see if we can generate some good conversation, but of course, if you want to raise a hand, please do so as well, panelists. And first, I will begin by briefly defining attestation, and I'm going to use the definition that we had in the RATS architecture webinar, which is attestation is the process of verifying that some system is in a good state for some value or definition of good, which is a very general definition. So to our panel, my first question is, do you agree with this definition? Would you expand upon it? Would you propose an alternative? And what would you say is meant by verifying the system state and what it adds in terms of security? And why is this critical to confidential computing? So it's a few questions bundled in one, all going in the same direction, but anything that brings to mind, please go for it.
I'll go first. I've given this question a lot of thought. So I used to tell people when I was doing our architecture work around attestation at Microsoft that when I say Dave Taylor has integrity, we usually would mean by that, you immediately kind of know what that means. It means that, Dave's a good guy. You can probably, lend him money and he'll pay you back, and he was not going to lie to you and cheat and all of that stuff. Machines don't know right from wrong. And the only way to really reason with the machine is have this other part is integrity with respect to a policy. So when you say the statement the system is in a good state, that is actually not correct. The system is a known state, and the system cannot lie about the state it is in, whatever that state is. Right? So the process of attestation is basically the irrefutable proof that the system has is running the code that you expect it to run in a configuration that you expect it to run it in. And both are equally important, right? Bad configuration can make good code do bad things. And when I say why I have an issue with the definition of good is because if I'm looking at a historical attestation statement, then it may be good as defined some time ago, and it may have passed some policy then, but wouldn't pass the policy now. But at least you know what to expect of a system in a given state. And so attestation is ultimately about irrefutable proof that the thing will behave in a way consistent with whatever code and configuration it is executing.
I was glad to see that Mark brought time into the equation, because I think that it's really fascinating that the definition of attestation does not actually talk about time. It talks about that a system is in a known state using the present tense of the verb. The problem with this, of course, is that no confidential computing technology actually measures that. What it measures is an initial state, which is extrapolated to be the current state through a trust that the system has a predictable behavior from the initial state to now. Notice that I didn't say deterministic because there's a whole variety of ways in which the software may not be deterministic, but nonetheless, the non-determinism is within specific bounds. But so basically, today when we do attestation, we're measuring the initial state of a system. We are assuming from that initial state that the state can't be tampered with, and that the state transitions, even though non-deterministic, are are trustworthy up until the point at which I measure them now. So that's a way more detail than we probably need, but I do think it's important to be able to talk about it in those terms, because we may want to consider, what does it mean to be in a good state? Well, if it was in a good state, 5 years ago, is that the same as being in a good state 5 minutes ago? And it probably isn't. So I'll pass on to my other colleagues.
Sure. I'll comment as one of the co-editors of the RATS architecture document from which the definition came about some of the discussions that led into that. I wasn't going to comment on the timeliness and freshness aspect, but thank you for bringing that up, Nathaniel. We can have a conversation about that because those are all great points. So once upon a time, if we go back, before attestation became popular, then authorization decisions, the closest thing that they could do was, how do you know whether an entity is been compromised? Is it actually, authenticating as the entity that it is? And so we had something called what was, at least in the IETF, called posture, right? You'd ask it, and you'd ask the entity, so are you in a good state? And it would say, yes, I meet all the following requirements. And again, for some definition of good, right? Does it have all the latest patches or whatever? You'd ask it and it would say, yes, I have all those patches. Of course, it can lie, right? And so the whole posture assessment was really, does it know the correct answer? Was the closest thing, right? Is it secure in a sense? Not like attestation. It's just it has to be able to know the correct answer, but it could still lie, right? If it doesn't know the correct answer, then it's out of date, right? And so it was more of an incentive to be patched. It was an incentive to be managed and so on, as opposed to some secure proof or level of confidence that it actually was in fact correct and not compromised by malware. And so that was the history where there was more posture assessments. When we use the term posture in standards, we mean more like self-attestation, which is not really our definition of attestation here, right? And so just like Mark was saying, there's no such thing as, objectively good or even objectively trustworthy, right? Those are statements from the perspective of a peer, right? Which we would call, say, a relying party, right? The relying party gets to decide whether something is good or whether something is trustworthy. It's a statement of the recipient's level of trust or faith or judgment about the state of a particular thing. So as Mark was saying, part of the job of attestation is to expose what the truth is in a way that can't be lied about. It's different from posture, right? Such that the relying party or some external peer can make a judgment as to whether that is then good or whether it chooses to place trust in it based on some policy, right? So the policy and the judgment is done by the relying party or by the peer. It's not a statement about the state of a particular device. It's a statement about your level of appraisal or faith or trust in that other entity. And so attestation is kind of those two aspects put together, the statements about what the truth is in a way that can't be tampered with, because they chain down to the hardware, and you're assuming that the hardware itself has protections against tampering, right? It's not like malware where you can, flash it or put things on there. It's more immutable, right? And so as long as it chains to an immutable root of trust, then the relying party can actually make some judgment based on appraisal policy as to, is that truth something that is good, because it's the thing that gets to decide what the definition of good is. So when you say for some definition of good, what we mean is the relying party's definition of good, which sometimes he will delegate to a management system, which we might call a verifier in this sense, to make that judgment on its behalf, because it trusts somebody else to make that judgment, but it's not putting faith in the software, say, running on the actual device performing attestation. So
I think there's a couple of responses to the things that have been said that your point brings forward, Dave. First is that I think Mark said that it was an irrevocable proof of the actual state. You don't know it's irrevocable until you've actually done that assessment by the second part. It's really an assessment of it. Do I trust all the information that was given to me, right? And then the second part, I think I wanted to pick up on Nathaniel's perspective about it's the initial state of the system. I think it's the initial state of the TCB that you're trusting, right? That may have been built much later than the boot platform. And I know we're going to get to what makes sort of like future of attestation and things like that. And one of the things we've learned over time, right, is trying to fully evaluate a platform from the very beginning boot to, some piece of code that is running, 20, 25 minutes later, is actually quite a difficult thing to do, right? People have done this. It's overwhelming, right? And what we've seen is, some of these TEs have tried to simplify as much of understand, what you've got to understand in order to make that good judgment call that the system is in a good enough state for you to transact with.
Yeah, thank you, everyone. These are awesome additions, and exactly the sort of conversation I had hoped for. I do see we have a question already. Thank you. I'm going to get back to questions towards the end, so we'll be able to address some of those, but please keep sending them in. Yeah, so going off of this, I want to ask, who is attestation for? And in what scenarios would it be advisable or even required? Are there some example use cases? And also coming back again to what makes this a critical technology for confidential computing?
I'm happy to kick this one off because when the IETF work was being chartered, I threw out a conjecture on the use cases. And so at least I'll currently call it the Thaler conjecture. And so far it's held up, and I would love anybody else who wants to weigh in on this topic, which the claim was that every authentication use case is a potential attestation use case. Okay. I say potential because whether the ROI is there to actually invest in doing it depends on the actual use case, but it actually would make sense. So usually you're trying to make an authorization decision. Okay, it's not the only case for authentication, but let's just say that you're making, for example, you're making an authorization decision, and you want to know who it is to say, is that entity authorized to make this thing? And so you're using authentication for the purpose of getting the identity to do an authorization check. Okay. Well, without attestation, you don't know whether that entity is really that entity or if it's been compromised by malware and hence is acting as that entity. So what attestation lets you do is it gives you a stronger faith in the level of authentication that it really is that entity and not malware trying to act as that entity. Okay, and you can't do that without attestation. So that's where that conjecture comes from as an example. And that's just the authorization example, but that's pretty common. I think people can relate to. So I would say by default, the straw man would be every authentication use case is an attestation use case. So.
And Dave, you would tie that back to that hardware root of trust, and that would be the difference between authentication and attestation in this case, would you say?
Yeah, so here the question was about use case, and I would just say all of them, right, is the straw man. And I would love to have the rest of the panel weigh in on. So
yeah, please, Simon.
I was just going to make the observation. I think that's why you see such an affinity just recently with TLS based use models for attestation, right? We've seen. I think Intel has looked at this several times, right? And we've come up with, I think, at least 2 or 3 different variations, but they all seem to revolve around that. I want to set up a session. There's authentication required. Okay, let's ride over the top of TLS. So I think that really sort of like goes to Dave's point around authentication.
I will have a couple of things to add, specifically, like, let me up level to the actual business use case here. So I quip that confidential computing has 2 classes of customers, the paranoid and the regulated, and the paranoid have no money. The regulated, however, have a lot of money. And the other thing that is worth noting is a majority of actual money is spent not on security per se, but on compliance. So as a bank, we operate in 80 jurisdictions. We have 5,500 pages of various regulations we need to comply with. We have 2,700 applications to prove compliance. In the there is all sorts of regulations there. Now, what attestation fundamentally is it's the TCP for the entire confidential stack that relies on it. And the other thing, if you like, just take a look at the history of regulations when it comes to information technology. It wasn't always the case that you had to prove that your network transport is secure, that your storage is encrypted at rest, right? It's only when technologies become available, then regulators wake up to them and they start demanding that you prove compliance with certain security postures. And I believe that as confidential computing becomes more ubiquitous, more of a stable, when cloud computing as a result becomes more of a utility, where you get, you pay for network traffic, storage traffic, and as I call it, janitorial services, but when they don't look, when the cloud provider is not supposed to look inside your workload, what the regulators will want to know is prove to us that you are complying with regulations around keeping your data secure, keeping your workload secure. And when it comes to that, the attestation statements become the basically that juice that the core of how you prove compliance with regulations. That's where actually the money is going to be.
Yeah, I'll just weigh in and say that I agree with both Dave and Simon. First, the question was asked, who is attestation for? And I think attestation is for everyone. I think that's the reason it's not today is because attestation is hard, and because it's hard, it's expensive, and because it's expensive, as Mark said, you have to have people that have money that can be able to do it. But there's no reason that attestation has to be hard. We can actually build attestation services which are scalable, and we can actually make this both easy and cheap. And when it's easy and cheap, then everyone can have attestation. And when everyone has attestation, it increases, it creates a new plateau in a certain sense of what we expect out of services. Today, when I make a connection to a remote service, I hand them my data, and I have no idea what they're going to do with that data, right? Do I trust them? Maybe, maybe not. I don't really know. And the reason I can't even make that decision is because we just simply don't have the primitives available to us to be able to do anything that is better than that, which is why it's really important for us to focus on building scalable, usable forms of attestation. I would also like to add that we also agree that there's an affinity between attestation and TLS. As Dave said, attestation is one input in an authorization decision. But one of the critical problems that we have is that we also have to secure the channels between confidential apps, because if we don't, then we actually weaken the properties of the network itself. And so the only real tool we have to do that besides SSH, which is probably not fit for this, is TLS, and that's going to require a certificate. And this is why Profian actually ships an attestation service that does precisely this. It validates an attestation and it issues a TLS certificate that's used by the keep when it's communicating to other parties. And this means that every time you establish a connection to another party, you have a statement within the certificate from the other end that's cryptographically validatable of what the initial state of the system was and what the workload that's actually running in that system is. And that basically forms the basis of your authorization decision. And in today's modern infrastructure, we do basically two levels of authorization. We have channel authorization for TLS, and then we typically also will have a higher level of authorization and authentication in, say, HTTP. And so combining these two makes an effective ability to gather all of the inputs to an authorization process and be able to make an intelligent decision. So Simon, your hand's up.
So I want to pick up on the "it's hard" comment that you made. The mechanics is not hard. I think the hard piece is that attestation gives companies that want to do risk assessment a new tool. And the hard piece is it exposes them to things that they might previously have wanted to ignore. And that is the hard piece, is the integration of understanding machine state into risk management decisions. I think you kind of hinted that in as I go to give you something, as I go to give up something to you, right? Am I good? Am I okay with that? Because if you don't get no system is fully up to date. And I think this is what Attestation exposes. No system is fully up to date. So where is your cutoff point? Right. And that will change over time. It's not going to be, and this is sort of like the timeliness piece, right? Is what you believe is okay today is not going to be the same in a year's time, because we will have seen, you know, hell, look at what we've seen as like new style attacks come against platforms in the last 4 years, for instance, right? The emergence of side channels, whether those be transient execution, or you look at telemetry type stuff that you can have access to, right? There's all sorts of different ways. Now, how paranoid you are or how much compliance you need, right, will depend on where that cutoff line is and what issues are due. So the hard piece, I would argue, is not the mechanics of the attestation and what the attestation represents, but assessing the risk. I'm trying to provoke Mark here into reaction, I think.
Well, I'll actually respond that I think the mechanics are also hard. Again, as someone who in a former job, I worked for cryptography, doing cryptography at Red Hat. So I was there for 10 years, and I can vouch that cryptography is hard, and attestation requires cryptography. And there's 1,000,001 foot guns that will get you if you don't do it correctly. And so it's hard, and even experts get it wrong. But even beyond the mechanics, there are still parts of it that are hard, that are more than just business-based, risk validation. So, for example, one question is, what does it mean to have workload equivalence, right? Because if you're running an application on multiple different TEE implementations, which you need to do for redundancy, how do you actually make the decision about which workloads are equivalent to one another when all you have is a cryptographic hash? Now you have to assign some sort of human meaning on top of this. And if you haven't basically baked this into the way that you do your TEEs, which footnote NARCS has, but you'll also have to build, if you don't do that, then you're going to have to build complex systems on top of that to track all of the measurements and determine which ones of those are equivalent to one another, so that you know when I have a bit of code that is running on a TEE on Intel or on AMD or on ARM, all of which have different cryptographic measurements, are those functionally equivalent for the purposes of risk, or are they not? So if you don't have something built into the core platform to handle this, you'll have to build pretty extensive meaning tracking on top of cryptographic hashes, and that is an issue that is entirely fraught with problems, even on a technical standpoint. So to do the base mechanics of validating all the signatures to determine a cryptographic hash, whether that should be trusted or not, it's on the easier side of hard. There's still lots of cryptography involved in that. But that still just gives you a cryptographic hash. And now you have to go turn that cryptographic hash into some meaning. And that is something that is really fundamentally hard.
Yeah, I would say it's the mechanics piece is deterministic, right? You can do it.
Yes.
The risk piece or the equivalence piece, right, is is less deterministic from my perspective. I mean, okay, I've been doing this for 10 years, so I sort of like take the mechanics as, oh yeah, I know how to build mechanics. It's the business-based stuff and how this integrates with the business. I really would like to, if Mark's got some perspective in this space.
I do. It's not one you're gonna like. So we operate private data centers. So again, speaking on behalf of my employer, we also have footprints in AWS, Azure, and GCP. Mm-hmm. And we have cross-product that with the number of trust execution environment technologies we have, both client side and server side, right? So you have, really phenomenal Azure confidential VMs with NVIDIA H100 confidential GPUs. You have upcoming hardware storage and network accelerators. When I connect to a system, I really connect to a load balancer, some sort of front end, and behind that, who knows what it does, right? So I encourage the industry to think about attestation as a Schelling point. How many management technologies do our people need to learn to properly attest environments across all of these providers, right? So Verizon has done the very right thing of relying on OPA, because the fewer policy management languages we have, the better. But when I say Schelling point, success in IT, when it comes to foundational technologies, such as attestation, such as TCP/IP, comes down to having as few things to choose from as possible, right? We do not want to manage attestation services differently for every technology and for every provider. It is unmanageable. And when I say it's unmanageable, it becomes undeployable, or it becomes excessively complex, or it becomes very error prone. So we need to start thinking about, the poor customer, trying to make sense of it all. And absolutely, at our level, at the level of highly technical people, it will devolve into how to make meaning out of a hash. Yeah, absolutely, that is correct. But when you get to a point of, we have a development team that does not have a PhD and 15 years of experience with confidential computing, they need to be able to say, let me explain what it is that I'm trying to run, and let some system convert this into a policy, and let me simply say, make sure that the thing you're standing up is as the designer has intended, something like that. So that's one dimension of complexity that we need to reduce. And the other thing that we need to address, and I don't know if it can be reduced, is confidential computing fundamentally shatters the, what is it called? The separation of duties that happens between cloud and customer. Where today, when I say cloud, I trust you to encrypt my data at rest. I trust you to operate your things correctly. But now I'm basically saying, cloud, I don't trust you. So I need you, Microsoft, to prove to me that you're running and configuring AMD's, Intel's, NVIDIA's environments correctly and staying out of my business. Right, so this shared responsibility model is what the word I was looking at. We need to have I don't know necessarily rethink it, but we certainly be thoughtful about what does it mean in the confidential computing world.
Mark, if I didn't know better, I would say you were gunning for a job in marketing at Profian. These are exactly the problems we are trying to solve. All of the parties here have been working in this area for a long time, and bringing up the core primitives on hardware has been incredibly hard. But we need to turn our attention now to these higher level problems. Questions like, am I going to have to teach every application how to do attestation, right? If that's our model, we will fail. In precisely the same way that hydrogen cars failed against electric cars. And the reason for that is that the infrastructure was already in place for electric cars. You just plug in the car to your wall. And this is precisely why we immediately convert an attestation into a TLS certificate, so that you can you just make a TLS authorization decision the way that you already do in all of your applications. And that is a direct cryptographic proxy for whether you're doing attestation. It also, by the way, hides all the details. It doesn't hide them, but it means you don't have to validate all the details of 100 different hardware configurations across different clouds, because they all look exactly the same. So we are trying to solve these problems. I think they are solvable problems, but I would encourage anyone who's interested in solving these hard problems to come talk to us.
So I will jump in here as the maybe the standards representative, because I think Mark and Nathan touched on an interesting tussle that's out there. If you look at the challenges and the trends that standards is kind of the approach that we're trying to take, where Mark talked about, do we have heterogeneous or homogeneous environments, right? Especially when you have multiple vendors and things that are involved, right? And so from the end administrator's perspective, like that maybe Mark is representing by proxy, that you'd like as much homogeneity as possible. On the other hand, as Simon talked about, right, you're never up to date. We always have new things coming in, side channels and so on. And so different models and different vendors want to close those new gaps and things. And so you have some homogeneity over time as different, say, attacks are mitigated in new types of hardware, new types of software, or new types of systems that mitigate those. And so you have vendor differentiation on one side, okay? You have a desire for homogeneity on the other side. And the other heterogeneity trend is if you go back a number of years, then you look at how, say, how TPMs came in, right? And so there's heterogeneity in terms of manufacturing jurisdiction, right? How many TPM vendors are there, right? Well, in China, for example, the only things that are authorized is things from Chinese TPM vendors. And similarly in other countries, you got to have a TPM vendor in their country, right? And so you have a lot of heterogeneity that says, okay, if I'm in China, I'm going to use a Chinese TE. If I'm in, say, America, I'm going to use a American TE. Or I'm in, Russia, I might use a Russian TE. And so if you're somebody that's running, say, a global banking system, then you might, again, have a mix of these in different data centers and different technologies and different jurisdictions. And so how do we deal with that level of heterogeneity, both in terms of multiple vendors that want to differentiate, you have different jurisdictions and so on. And really, at least from my perspective, this is the role of standards, which is not going to solve all of them, right? Because it does not remove the ability to have vendor differentiation, right? But it does help to provide some homogeneity in the case of things like multiple jurisdictions, multiple vendors that, in the past, before we started having standards, then we had plenty of attestation that was out there, but it tended to be vendor proprietary systems. And we're starting to see more and more convergence there, which helps operators and end users like Mark is representing to say, okay, let's say I have, an Intel and an ARM and a RISC-V and an AMD. Is there any homogeneity across those or not, right? And so open source and standards are really where those advances are happening that says, let's take the things that are common, right? Yes, there's going to be differentiation. It's going to be new things. We want vendors to innovate and so on, but other things that are common, can we provide some homogeneous layer that says I can manage them as one set? And that's where things like standards out of IETF, TCG, and so on come in, as well as open source projects like Verizon, Open Enclave, NARCs, and so on, are trying to provide a homogeneity layer that does not necessarily remove the ability to have vendor differentiation, but that's kind of the tussle, right? You have trends towards homogeneity and trends towards heterogeneity, and will kind of always be somewhere in between with a mix of both. So.
I just had a flashback listening to you, Dave. This is I'll date myself. Like in the early 90s, I was an intern at IBM. And I was given a computer, and in order to have that computer connect to other computers on the corporate network, a specially trained person had to come to my office and basically, participate in a set of incantations. And that was the day when you had twisted pair, and you had token ring, and you had Banyan vines, and you had this, this smorgasbord of solutions just to provide this very, very basic functionality of connectivity. And consider the difference between that and now, when it's virtually painless. It really comes down to pushing a couple of buttons, and maybe my grandma, 97 years old, still can't do it, but certainly my very non-technical dad can. So this is when I keep stressing the point, maybe it's very aspirational yet, of a Schelling point. We will absolutely have differences between vendors, but you don't need to know right now what my Wi-Fi router is that sits between you and I, right? Because it's been kind of a figured out problem how to manage this thing and how make sure to keep it up to date and how to make sure it complies. And I think this is where we'll end up happening. I'm a little bit more optimistic long term that we will be able to converge on fairly painless, management of ensuring that everything stays up to date and according to policy. It will probably take a very significant amount of effort.
Great. Thank you very much, everyone. I have not wanted to interrupt because we're doing such a good job covering these important topics and the complexities, the multiple types of complexities involved in attestation today, which I think is great. I did want to make sure that we also talk about other trends or gaps that we see in attestation today. We've talked about the complexity, We've talked about some of the stumbling blocks that we've had. Any other comments on where attestation is going? Since, of course, this is about the future of attestation and where we would like to see it go.
I think there is this. We've certainly seen from customers that Intel has spoken to, right? This desire to be able for it to be able to not have to write to one interface for a specific cloud vendor or a specific data center vendor, and so it's not just going to be about standards at this is the bits that you get down the stream, but certainly okay. As I go to find out these things, where I hand them over, I've got a service that I can go and give that to, right? So we certainly made an announcement around Amber, which is built on public components that we have had, not necessarily fully open source, but public components, and turn that into sort of like a service offering. Now, I think Nathaniel's talked about, his capabilities, and I would imagine that we'll see more of that. It's been interesting. I look at the history of attestation, and one of the reasons that when I sat and was working on SGX like 10 years ago, maybe a bit longer, we were looking at the TPM going, why isn't the TPM being successful? Because no one is building the services that go along with that. That was our conclusion. And to a certain extent, we did that for client SGX. We wrote back a little bit at the data center, and we're going back to that story again. And I think if people aren't building those services and making those available, so like the big guys, I don't think the attestation will be. You need those things to really sort of push that ecosystem through.
Well, one of our perspectives on this, and I actually suspect that probably everyone will agree with this, is that whoever is hosting the workload should not be the party that is also hosting the attestation service.
It can, so long as they remove themselves from the TCB. So Microsoft Azure Attestation Service, Dave, please correct me. In fact, it self-runs in enclaves.
Yes.
And it is I worry if we do what you say, Nathan, that if the attestation service is hosted off-prem, it might become a very significant bottleneck because of the amount of traffic that has to go to and from, and certainly possibility, but I would be worried about scalability. I do take issue with AWS's approach, where they literally own the entire stack: hardware, software, management, policy, staff, right? So, and they made a conscious decision to stay firmly planted in your TCB. And if you go to AWS, I would not even call what they're doing confidential computing.
Dave, did you have something to add?
Yeah, so I think first, if you go to the as the audience, we have a confidential computing. One of our white papers is about the technical analysis, and one of the points that it makes in there is that one of the goals is to remove the operator of, say, the service from the set of entities that you have to implicitly trust, right? And so it talks about that in more detail. And I think that gets to Mark's point about, if you've done a good job, then it shouldn't matter who's hosting it. What matters is who has admin control over the contents of it, right? And so let's say Microsoft is hosting it, but JP Morgan Chase has admin control over the contents of it, right? So that's okay, the fact that Microsoft is hosting it. I think that's what Mark is getting at. On your question, Lily, about the gaps and trends and stuff, I thought I think in the chat, Tom brought up a great question that I wanted to touch on, because I think that's actually one of the larger issues, which had to do with levels of compliance and regulation and so on. Because if you look at recent attacks, even in, let's say, critical infrastructure, perhaps one of the most dire cases, right, where you have danger to life or environmental damage and things. And so you look at recent attacks, like over the past couple of years, things like Triton, which took out the petrochemical plants in Saudi Arabia and power and so on. Some of the more dangerous aspects you might think are great use cases for confidential computing. Well, the systems and those types of attacks are already certified at the highest levels of the regulatory things that are out there right now. So IEC 62443, for example, is a popular one in many industries. And the systems that are taken out are actually compliant at the highest level of that. And so, well, why is that? Well, what they're missing is the sorts of things that confidential computing brings in, okay? And so one of the problems that we have right now that Tom is really alluding to, I think, or at least my perspective, is that one of the gaps right now is that vendors to supply to those types of things, there's no checkbox for, do I have attestation with a hardware root of trust? Is there confidential computing protection? Things like that. Is there a way to differentiate? And the answer is, right now, the regulations have a gap that's there. And that's what I think Tom was pointing out, which is something that I find fairly concerning. And that's something as an industry, we need to work together to get those into the regulations. And so that's not answering Tom's question. That's explaining to the rest of the audience why Tom's question is actually quite critical. That the sooner we can get things in a regulation, that means the better opportunity for vendors to differentiate and people to be rewarded for actually solving these problems. And that's what will actually make the world safer, right? So the Tom's question is so critical. It's like, how soon can we get that? Because as soon as we can get that, the world starts to become a safer place. I would love to live in a world where my kids are safer than we are right now. Okay, that's what kind of motivates me in confidential computing. And so this is something that we really have to work together. I don't know what the time frame is, right? Because I don't have a great answer to Tom's question. But if I look at gaps, okay, I think that's one of them. And that's certainly something that within the confidential computing consortium we formed to form a collection of companies with similar interests, right? It's something we have to work together. And I would call everybody else that's on the attendee list here. If this is something you have any influence, if you work for a company or an organization or have contacts at a national delegation that participates in these discussions, we really do need to get these things in a regulation. It's something we have to work together on to try to pull in this timeline. So I don't have a great answer, but I agree that we have to call, and this is one of the most impactful things we can do. So
thank you very much, Dave. Since we're talking about this, does anyone else have comments on these gaps or like possible timescale to answer this question, which is, what do the panel think will be the timescale for these regulations to demand confidential computing and attestation?
So I'm optimistic in the midterm, but I'm pessimistic in the short term. In the short term, the cost is simply too high. We need efficient systems to be able to deploy apps at scale using confidential computing. And because the cost is too high, basically, if regulators attempt to enforce this, they're just going to get too much pushback. Because it would be too onerous of a requirement on businesses. We need to get to a phase where it is cheap enough that we can basically allow confidential computing to be a regulatory shortcut, meaning that you have basically two paths that you can choose. One is the confidential computing path, and the other is the more traditional path. But the more traditional path would be more expensive, where you can just bypass a lot of this stuff as long as you're using confidential computing. And this provides an economic incentive without requiring everyone to adopt confidential computing. That's where I think we'll start to see a real sort of watershed moment for confidential computing. And then, of course, the last phase is precisely when the regulators require it at different regulation levels. And this is something I think we're all hoping that we get to, because it does provide real benefits to the industry. But I hope we can get there in an incremental way. But we have to reduce the cost of adoption in order to make this even plausible.
Any other thoughts on that, as it seems pretty critical to our conversation about the future of attestation?
The regulations are written in a funny way. They do not usually, they're not prescriptive. They're usually descriptive. And they will typically say things like, you need to, ensure that, data is safe from disclosure, or something like this, right? They don't say, at certain level. Then it translates into what's called control procedures, and they're also a lot more prescriptive. And I believe, again, when I say to my previous point, the sooner we get to Schelling point status, the easier it's going to be for regulators to formulate requirements and for us to prove compliance with these requirements. And also do not forget how many regulators there are. So JP Morgan is subject to something like 78 different jurisdictions, although I'm sure it changes. Some are regional, like GDPR covers all of Europe. Some are industry. so like PCI DSS. Some are federal, right? So they will have something that's US wide, or some are state, New York, California, right? Singapore, right? So all of them have their own, take on things. And again, all of these different takes are better converged to a relatively small and manageable set of primitives that your regular Joe developer should not have any, much difficulty complying with. And I do believe we'll get there. It's just the more the industry is fragmented, the farther that goal is, and the more we focus on converging on things like policy languages and, like Dave said, a set of standards and protocols, the easier it's going to be. So that's going to be the, if you're building your own attestation service and you're creating your own management language, policy language around it, you are in the way of a Schelling point.
Yeah, so that's a great reason to come back to the attestation special interest group and then CCC as well, just to plug that. Dave, I see you have your hand up.
Yeah, so triggered another thought as I was listening to my colleagues here speak. One of their challenges of getting, so this is the point about, I think, Nathaniel, you said you were optimistic in the eventual, but pessimistic in the short term. And I think one of the challenges in the short term is when you look inside the regulatory discussions and the regulatory bodies, right, that the things that demand or motivate confidential computing is only one of the constituencies in the regulatory discussion, right? The other often counter, I'll put it that way, often counter constituency is lawful intercept, right? And so that's one of the reasons why it takes them a long time, because you have lots of people from, say, the lawful intercept side that want to make sure that they have the chance of doing things. And in many circumstances, right, that is kind of a tussle that competes with the goals of confidential computing as to how do you find something, what's the right thing to regulate when you have both of these constituencies that want to play in the overall cybersecurity space. So like a couple of years ago, just before COVID started, I was a panelist in a cybersecurity summit hosted by Texas A&M. And the panelists, we had one person that was from the FBI. We had me there from confidential computing. And then we had a black hat person with that was like an ex-hacker that had gone into the security consultant business, right? And so we had the three of us as the panelists in this one, and it was actually a great discussion about, what's the right thing for cybersecurity. And of course, which position I was advocating, because that was my role that was on there. But my point is, the same sorts of discussions, what happens inside the regulatory bodies, and this is one of the reasons why short term it's very difficult, right? Because the cost aspect that Mark mentioned, plus the fact of getting agreement within regulatory bodies takes a really long time because of tussles like this. So.
I like to make this point that and this is the thing that Mark Rusinovich and I had a conversation some years ago, where I basically said, I want the cloud to be a utility. What I mean by that is I buy water and electricity from a utility company, but I do not have the representative sitting in my living room observing what I do with the water and electricity. Yeah, it's entirely possible I'm electrocuting someone or waterboarding someone, but if they want to know if I'm not doing that, they probably need to serve a warrant. This whole lawful intercept is very correctly in confidential computing and needs to go away. And I think we need to enable something like that to go away, because a cloud is not a license for a nation state or government to go and do effectively extrajudicial warrantless surveillance. We should not make that easy. We should make that hard.
This is a great point. Simon, you have your hand up, and I'm going to take one question after that.
Oh, I had a really bad line interruption there, so I hope that's not my end. On the gap side and the regulation piece, I think one thing we tend to forget is we're at the very, very early start of confidential compute. What do I mean by that? At the moment, we know how to protect workloads that are happening on the host processor. We're starting to see emergence of, well, when those workloads move to other devices, that there are other mechanisms being proposed, right? And we know that the IO guys are starting to look at providing, protections to IO devices. That's a few years down the, fully a few years down the pipe yet. So I'm not sure that we have all the technical mechanics in place to say no matter, at what time, at what place that compute happens, that it's confidential. And I think that's a role that we have. It's not just a matter of a software ecosystem, but there's actually a hardware ecosystem we've actually got to build out to enable that sort of that confidentiality. So from my perspective, that's what confidential compute is. And I think only until we understand what that fuller picture looks like will we really start to see full regulations starting to appear. Regulating just the host processor doesn't help if you're actually doing most of your computations on a GPU, right? So or some other highly specialized, because that seems to be the way things are going. We're going towards specialized compute, right? Even within the data center. So I think until you solve that problem, I think it will be difficult for full regulation to emerge.
Also a great point. Yeah, I want to make sure, I know we have a few audience questions left. I believe several of them have been answered in the chat already. There is one. The gist of this is attestation is not yet properly specified. The attestation mechanism is underspecified and has some conflicting information. If anyone has a response to this one, we have just a few minutes left. I would say 2 or 3 minutes.
I think it's
that one was specifically directed to Simon, but I'm always happy to comment on the general IATF stuff. But
this is specific to TDX.
It was mentioned as an example, but it seems like it can also be generalizable in terms of standardization.
Yeah, I'm not sure that we want standardization yet, and I know that sounds odd. We need enough time to experiment to make sure that we are doing things and common patterns will emerge, and that's when standards are most successful, is when it clearly becomes apparent to the industry that there are some best practices, and and that we can adopt standards to codify those best practices. I still think it's too early. I mean, if we've already been talking about doing confidential computing on other things that aren't CPUs, what does attestation look like in those cases? The answer is we don't know. And if we try to standardize something right now, we're going to shoot ourselves in the foot, and then we're going to have to create a second standard just to solve the problem with the first standard. So I'm actually bearish on standard in the short term, but bullish in the medium to long term. I think that once the common usage patterns are identified, once people begin to start adopting these things at scale, using the existing experimentations that we have, that we can then start to begin to standardize this process. I will say that the existing attestation mechanisms provided by all of the parties are woefully underdocumented. I can say this as someone who's implemented all of them, that there is a number of very big questions. I have resolved all of them, but it didn't come without much pain and implementation. So that's definitely something we can improve on in the short term.
For sure. Dave, I see you have a comment, and then we really only have probably about 1 minute. And
I'll be short. I'll be short. In the IETF, I think the position was very similar to what Nathaniel said, is that it's often, it may be too early for the protocol. So like when the working group that does attestation was chartered, they were chartered to do some common message formats, but not the protocols to carry them. So like a certificate, that kind of thing, or an EAT token, if you're familiar with the RATS architecture. And it's because of that. There's so much innovation still happening. There's so much heterogeneity that they weren't ready to pick and bless, 1 or 2 so far, right? And so I think the main point is really the specification is what's needed. And I think the questioner would probably agree with that, and not necessarily the standards, but to make sure that what is out there, even if they're vendor proprietary, that they are actually specified and understandable. And I think that's what we're calling for right now. So thanks.
Thanks very much. Yeah, this has been a great conversation. It's exactly what I was hoping would come out of this as we cover the current state of attestation and the gaps, and also some of the things that we're doing well. So I wanted to thank all of our panelists for being here today. This was great, and definitely also thanks to the Linux Foundation for making this possible. If you are interested in this topic, again, please check out the other webinars at confidentialcomputing.io/webinars. I know that we have also more interaction from the audience that we would like to engage. So if you want to reach out to us, please look at the webinar description. You can get on the mailing list, Slack channel. We look forward to hearing more from you. Thanks, everyone.
Thank you.
Thank you.